Hi, welcome to VLSI DFT Basics course. This course has been designed from industry perspective. I am Awais Hussain, and in this course, you will learn about the invisible skills which are applied in the chip designing, and they are not too much visible. And this skill, DFT, design for test, is critical, which is essential to make any chip run successfully. So design for test ensures that the chips are not only functional, but they also make sure that the chip is reliable, like if we change temperature, voltage, current, and they will be operable. And also it's manufacturable, like to make sure that the chip can manufactured properly. And it helps the companies to be cost effective by saving to go through all of the cycles if there is something goes wrong. And this course has been built directly from my industry experience, because I really wanted to design such a course which is missing on internet at all. So by the end, once you finish this course, you will have a strong foundation in both the concepts and the workflows being used by chip designers, DFT designers in different industries every day. So in the semiconductor world right now, testing is not an option. It is necessity. We cannot tape out any chip without testing it. So it cannot be deployed in the system until we make sure that the chip is working properly. Just imagine like you buy a CPU from any place and it has not been tested. You take it home and it's not working properly, it's broken, something is wrong. So what will be your reaction? So same thing applies to all kind of chips. We need to make sure that the chip we are giving to the customer should be okay. So that's why we do this design for test, DFT, to make sure that the chip is working properly. So DFT actually is quite complex area compared to RTL, synthesis, physical and static timing analysis, STA. So, and also if you want to do DFT, then you should know about RTL, synthesis, physical, design, STA, silicon bring up. You don't need to be expert in all of these areas, but you should know some of the basics, and at some point you just don't need basics, but you need more than basics in from these areas. So DFT is quite complex area compared to all other areas, and academic exposure is quite less in this one for DFT. Maybe you have taken some courses related to digital design, related to analog design, but they all focus on different areas compared to DFT. So we have almost next to zero exposure in academia, especially related to DFT. So even if you have studied, it will be only like few courses, not few courses, I would say like there is some few chapters in the courses, few lectures. Another reason why I wanna develop this course is that I want to teach about like which tools to use for DFT. So at the end of this course, you will be able to understand and you will know that which tool is used for which purpose in DFT, because there are a lot of tools. There is a huge tool chain for DFT and it's not clear which one is used for which stage. Another motive for this course is that the training, proper training, structured training is missing for DFT. So this is another reason I wanted to develop this, because I have taken some trainings from tool vendors and which are quite expensive, and they do not go through like proper basic concepts. They either teach like too complex, which are quite hard to understand in the start, or they go super basic. So there is we need to have some balance in this kind of training. And how to learn, like for newcomers is quite big area compared to, for example, RTL design or synthesis or APR. There are proper structured courses, but for DFT, because there are so many stages we need to do, So there is no proper training mechanism already, like how a newcomer can overcome this area. So these are few of the motivations that helped me to do this course. And why you wanna learn DFT? So the purpose of learning DFT is because one is we want to make sure our chip is reliable, and to make sure that before we ship the chip to the customers after manufacturing, it is working properly. And we want to reduce the manufacturing cost, because by doing DFT, we are doing automatic testing for the chip, and it helps us to do quickly testing, which enables fast turnaround time. So it helps us to reduce the manufacturing cost. And it also helps us to improve the yield and debugging, because through DFT, we are able to diagnose failing chips quickly, and it helps us to optimize the manufacturing yield. Like we are quite quick to find out the failing chips, and then we try to find out the root cause behind failing chips, and then we improve the yield using that. And for the modern complex design, it is impossible to tape out them without DFT. So for SoCs, different CPUs, GPUs, and because right now it's the age of like AI, so without DFT, it is almost impossible to test these kind of chips. So DFT is essential to manage the test complexity in these designs. And from the career perspective, it is quite advantage, because right now DFT is in quite high demand across the semiconductor industry, and there is shortage of good DFT engineers in DFT industry, because it is quite complex. So a lot of people don't want to join this compared to backend or synthesis or RTL coding. So this is why I would suggest to learn DFT from the career point of view. We need to learn DFT also to meet the industry standards. For example, if we tape out some chips which are related to automotive industry or biomedical devices or related to defense, so they need to follow some proper structure and they need to follow some proper standards. So in that one, we need to learn DFT for that one. Before we begin, I would like to give a quick introduction about myself. I have done PhD in electrical engineering from National Central University in Taiwan. I have been working extensively in different semiconductor industry companies. I have worked on different areas of digital IC design, ranging from image, data, video, biomedical signals processing. And recently I have been working on DFT for automotive and non-automotive chips. And I have worked also on the software side related to AI algorithms especially, and data compression for different kind of data. This course has been designed for several audiences in my mind. So for fresh graduates or early career engineers who are entering like digital design area, verification or backend, and they want to know about DFT, this is for them. And for those people who are doing like especially in RTL, synthesis and physical design, because they have to deal with DFT at some stage of their chip, so they should know about basics of DFT, like how different components of DFT are working. And DFT engineers and flow developers are also target audience for this course, because for the beginners and for flow developers especially, they don't know like how many areas of DFT are there and what kind of areas they should target in their job and how they will do their flow development job. And also for DFT engineers, it's quite big world in the start, so they get confused like what's the difference between scan, boundary scan, analog IPs testing, a lot of different test modes. So this course is for them. And for the graduate students or undergraduate students who are doing study right now and they want to know about DFT and want to build their career in DFT. So this presentation will give them good idea about DFT and what kind of work is being done in the industry related to DFT. And for the prerequisites, I would recommend that to get the most out of this course, you should have basic understanding of digital design fundamentals and digital design concepts, like for example logic gates, flip-flops, multiplexers, finite state machines. And from the synthesis point of view, I would recommend that you know about like basics of synthesis, like what happens when we have RTL code and it becomes gate level netlist, and what are the basic constraints we use during synthesis, like related to, for example, clock generation or related to IO delays. So these are like the basic. Even if you don't have advanced knowledge, it's okay, just the basic concepts are okay. And from the timing point of view, for timing analysis, you should know about like setup time, hold time, clock domains, like different clock domains, and different paths like asynchronous, synchronous. So some familiarity with these kind of flows will be really helpful to understand DFT. And if you're completely new to this DFT area and also to kind of like chip design, you're learning basics, so I will make sure to explain all of the technical terms along the way so you can understand it much better. So why this course when other resources are available to learn DFT? Based on my own experience, when I was learning DFT, I could not find some course which was like properly structured to learn about DFT. I found some courses, but either they were quite simple, which were not related to actual industry implementation standards, or I found the courses which were quite complex, which were going into advanced mode from early on. So for the beginners like me at that time, it was quite hard to understand. I needed to study so much and spend a lot of extra time other than taking that course. So for this course, I have made sure that the content in this course is directly coming from industrial training material. So this is the same kind of material which I used in industry when there are new DFT engineers. And second is, which is really important compared to other courses, I have included details about analog IP testing, because these testing are totally missing from other courses and is quite important also, same like other DFT methods. And third is, you will learn this is something new, which I did not find in any other courses, like in details. Some give like super basic introduction. I have included in more details in this course. So I have introduced industry standard flows, which we actually use for DFT implementation in industry. So these are non-existent almost in other courses. So this is something unique in this course. And I have made sure that all of this is in easy to understand language, because I know a lot of beginners will be taking this course. So I want to make sure that they can understand it properly. And last but not the least, because it took me so many months, years to learn about DFT, and which I think can be optimized, can be taught to other people using simple language and using a proper structure. So in this course, I have made sure that the things I learned in many months, I want you to learn same things but within few hours. So this is another speciality of this course compared to other courses. Before we dive deep into the course, I would like to introduce the course contents for this course. So we will focus on why, what, how. These will be three main themes of this course. So first we will focus on like why we want to do testing. What's the purpose of testing? Why we should do testing. So this will be the first stage of this course. And the second will be about the target of testing, like what actually we are testing. What are those things like memories, flip-flops, what exactly we are testing. And the third will focus on how, like how, okay, we have identified the purpose of testing, and then we know which is our target for the testing. Then we move towards the how we do testing of those targets. So this will be the third main theme of this course, where I will teach you about the basics of testing methods. And in the last part of this course, I will give you deep dive into the basic DFT implementation flows which are being used in industry right now. So these are exactly the flows which we use in industry when we do DFT implementation.